Alright boys, we're talking angles in this one and we're looking at can we calculate and describe angles. It starts off on a pretty small baseline, just being can you describe the different types of angles. Keeping in mind that we'll probably venture into some of the more complex ones as opposed to what you've done in years previous. So let's look at first of all the basics. So of course we've got our small ones, which are our acute angles. Keep in mind acute angles measure anywhere from 1 degree up to 89 degrees. Another way you could describe it is just an angle that measures less than 90 degrees as well. Then we've got our big fellas, we've got our big obtuse boys. Those angles are ones that are greater than 90 degrees, so they are more than 90 degrees, but less than 180. So anything from 91 up to 179 degrees. Then we've got a nice easy one. It's called our straight line angle. It's just one straight line and it measures 180 degrees always. Only one measurement for those. I've just realized I've skipped one in between acute and obtuse as well, which would be our pretty easy right angle, which is our 90-degree angles. And then, of course, we've got the reflex. So reflex would be an angle that's greater than 180 degrees and less than 360. So they're the ones that normally look like something like this, and the angle goes all the way around the outside. Just remember when you're calculating a reflex angle, if you get an angle like this, what you would do is, we know that this angle here is 180 degrees. So then if you were using your protractor, all that you would have to do is measure this angle here to this point and then add on 180 degrees to it. A few boys got tripped up with that. If you need more info on that, if you look at the other videos on measuring angles using a protractor, that should be able to help you out as well. Remember, we've got that one called our revolution angle as well, which is a full complete turn angle that measures 360 degrees. You don't have to do much work with those, but one thing you definitely need to have at the top of your mind is that angles are a measurement out of 360 degrees. So 360 degrees would be a full revolution. Let's talk about calculating angles on a straight line. Fairly simple, especially if you know the main rule. We all know that a straight line angle measures 180 degrees. So on a test, on a workbook, in real life, if you need to calculate angle size, especially angles on a straight line, it's pretty simple. Keep in mind that tests, workbooks and stuff, the angles won't always be to scale. So unless it asks you to measure an angle using a protractor, don't do it. You should be able to use mathematics to solve it. In this case, we're told that this angle here is 50 degrees and we're asked to find the missing blue angle here. So all that we would do, we know that the full straight line angle is going to be 180 degrees. We know that this little segment is 50. So that means if we take 180 and take away the 50 that we know is there, the remainder, so this angle here that we've been asked to calculate, I've made it messy, is going to be the answer to this subtraction problem. So 0 take 0 is 0, 8 take 5 is 3, 1 take away nothing is 1. We know that the missing blue angle is equal to 130 degrees, which is why I've got my degree sign. As long as you know that calculating angles on a straight line always equals to 180 degrees, you can't really go wrong there, especially if you're practicing your subtraction algorithm. Even if they make it harder, like sometimes they'll give you ones that look like this. And they might say to you like, let's say this is equal to 45 degrees. And they might say like, what's the missing blue one? Here, you don't even really need to do much maths, especially if it doesn't ask for working out. We know that this one here is a right angle, so it's going to be 90 degrees. We know that 45 is half of 90, so we know that this blue must be equal to this one, and that one must be 45 degrees as well. If we really wanted to check if we're right, we could do 45 and 45 is 90, and 90 and 90 is 180 degrees. We know it's a straight line angle, and it should equal to 180 degrees. Let's take a look at some examples if they're not on a straight line, but if there's angles that meet at a point. And like magic, it appears. Sorry for the dodgy handwriting. Not my best stylus work there, but I'll be able to explain it to you, and hopefully it makes sense. So remember, when we calculate angles that meet on a point, we need to keep in mind that a full circle is 360 degrees, which means all these angles that meet at the same point, their sum, the total if we add them all up, should equal 360 degrees. Now in this case, it hasn't asked you to use a protractor, so we should be able to calculate using mathematics, and I'll translate my writing for you as well. So this angle here is equal to 115 degrees. This angle here is equal to 160 degrees, and this angle here is 65 degrees. So the first step that we're going to do is we're going to add up all the ones that we know, because we're trying to calculate this missing one here. Let's call it x. So if we do 5 and 5, we'll find that it's 10, carry the 1. 6 and 6 is 12, and 2 more would be 14. Carry our 1. 1 and 1 and 1 is 3. So we have found out that 340 degrees has already been indicated and measured on our full point here. So to work out what's missing, we would take the full 360 degree rotation, we would take away the 340 that's already been accounted for, and we will find that 6 take 4 is 2, 3 take 3 is 0. We know the missing angle x is going to be equal to 20 degrees. They'll try to trick you up by giving you angles that look a little bit difficult, but if you add them up, keep in mind angles on a point should always add up, to 360 degrees. The last one that's worth going over is calculating vertically opposite angles. These are the ones that look really confusing, but remember they're actually pretty simple. So let's say, for instance, I don't know why that control box is there. That's confusing. Let's say that you're asked to find the missing angles. So you're asked to find angle B and angle C. Remember, the rule for vertically opposite angles says that if there is an angle directly opposite that meets on a point, then it's always going to be equal. So in this case, we can clearly see that 105 and 75, if we added them together, that would be equal to 180. So we know that angles like this on a straight line are 180. So that means on the other side, it's going to be exactly the same thing. So if we look vertically opposite, we can see that angle A should be identical to angle C, and angle B should be identical to angle D. So in this case, angle B is going to be equal to 75 degrees, and angle C is going to be equal to 105 degrees. You probably won't be asked to show working too much when you're asked to find vertically opposite angles, but this counts as my working as well as my answer. It proves that I understand the concept and know how to calculate angles in that way. Good stuff. That was a tough slog. Angles are fun.